So first off, we want to download and install Wireshark on our computer. So depending on the operating system you have, download the correct Wireshark software for your system. Right from the Wireshark website, wireshark.org/download.html. So after you download your specific .exe file, you're going to want to double click and run that download file. Wireshark's a fairly big program, so it's going to take 10 to 15 minutes to install. During the installation, it'll ask you about installing WinCap. You'll also want to install that too, so click OK. So after running and installing Wireshark, the following screen will appear. This is our Wireshark Network Analyzer homepage or dashboard interface. So now that we've successfully installed Wireshark, we want to start learning how to configure the software and start capturing packets in networks. So take a look at the figure on the next slide. The highlighted red box shows you from which interface you want to capture packets. So on that same dashboard you see here, on the far left, the interface list. So for the network I'm on, these are the only items I have available. So obviously if you're in a business or corporate environment, you're going to see a much larger interface list. But for me, I have internet, I have a Bluetooth connection, so not much going on here. We'll run our first test via my Wi-Fi. So like I mentioned, this is just a list of all the interfaces my operating system has. So like I mentioned, let's do a test run with my router to monitor all my traffic flow within my network. So one nice hack we can access via this initial capture is anyone who has unauthorized access to my router or Wi-Fi. I'll be able to find their IP and MAC address. So now let's go through what basic things I want you to select in this edit interface settings. So the first option is the link layer header type. So by default it's Ethernet. The only reason you should select DOCSIS is if you're capturing traffic from a Cisco cable modem. But for the most part, the default's going to be safe here with Ethernet. Next, make sure to check mark Capture Packets in Promiscuous Mode. Normally, a network interface will only receive packets directly addressed to that interface, but Promiscuous Mode allows the interface to receive all packets that it sees, whether they're addressed to that interface or not. So this way, we're getting all the data. The next option is limit each packet to number of bytes. This field allows you to specify the max amount of data that you'll capture in each packet. Sometimes you'll hear people reference to it as the staple. So basically, if you don't checkmark this, the maximum it will set at is 65535, which is really sufficient for most protocols. And remember my rule of thumb. If you're unsure, leave it at the default value. One example you would adjust this for, say if you only need the IPs or TCP headers, you may want to choose just a small snapshot length so it doesn't take as much time and buffer space to create these packets. And sometimes when these packets are really big, they'll be what you call dropped off. So that means they just kind of stop capturing if the traffic is very heavy. So if you're capturing a very niche area of the traffic, that's when you want to do a limit each packet. Otherwise, not checking it, letting it go to the default is fine. So like I mentioned, sometimes when you capture all the data, the packet will drop off. So you'll have to reassemble this data where you pick up in your next capture. So that's why I said that limit each packet comes into play. But I like to leave that one at default and instead set the buffer size to 2. So this buffer size is the size you will keep the captured packets until they're written to your hard drive. So if you encounter these packet drops, I just like to bump up this value. We'll start with 2, but if you get a capture drop, let's just restart it and increase this buffer size. The final options are capture filter. This field allows you to specify a capture filter. So I'll discuss capture filters a lot more in later slides, but the default is empty or no filter. So we'll just start with that. But if you want to start with one of the capture filters, or at least look at the dialog box, click that capture filter button and you can scroll through and see your options. But we'll be discussing those more later. Finally is the compile BPF. This button allows you to compile the capture filter into a BPF code and then it pops up in a window showing your pseudocode. So this can really help the understanding the working of the capture filter you created. We've already edited what we want to capture, so let's select that Wi-Fi and then click Start. So once we do this, the packet capturing will begin. So here's a screenshot of that actual live capturing from my router network, or Wi-Fi. So as it captures, it's going to break it down into 3 separate categories. So the top part of this capture first shows the number of the capture, the time of the capture, the source and destination address of the capture, what protocol it was, the packet length, and finally the info. So in the second category, or second window, it gives you more insider info about the packet. So remember the OSI model, including layers 2 through 7. This is data specific to that model. And finally, the third category, or third window, this shows the overall hex value for the selected packet. So we've installed Wireshark, the setup's complete. We've already run one test on our own router. So now let's move forward and learn more about capturing, configuring, and more deeply understanding the usage of Wireshark.